In a previous lesson, we looked at creating custom classes and creating instances of those classes. And just to review that, we create a class that has attributes or properties, has a constructor to build an instance of that class, and may or may not have some methods that do some things to that instance. In this case, I have my class definition, and I can call the constructor of my class, passing it a color argument, and it will create an instance of that house and change the outside color of that house. Now, this is not drawing the house, but this is giving an idea of the color property or the outside paint property. So I create one here called a yellow house. That's my object name or my instance name equals my class, and I pass it color.yellow, and it would create a class with the outside paint property set to yellow. I can create one that's green, and I can create another one that's red for my red house. So those are instances. Each one is unique, but they're all based on the same class definition. Now, I mentioned that there are pillars, 4 pillars of object-oriented programming. And so within the instantiation, we might use one or more of these pillars in defining our class or classes. Encapsulation is the most common, is where we will start. And encapsulation is the idea of hiding data from another class. It's protecting that data. We also have inheritance, where we can have a superclass that is inherited by a subclass, and it inherits the attributes or the properties and the methods of that superclass. And you can have several levels of inheritance. Polymorphism is the idea of having a method that behaves differently in different subclasses, or maybe the same method within a class, but is using a process called overloading. And overloading is a type of polymorphism. I mentioned in the previous video that I tend to think of overloading as maybe being a 5th pillar. It really is part of the polymorphism pillar. But I tend to use overloading maybe more than other areas of polymorphism. Another one is overriding, where we can have a method in a subclass override the base class or the parent class method. And that's what I typically think of as more as polymorphism. And then abstraction is we can create an abstract class that cannot have instances made of it, but require concrete classes or other subclasses from that that may have instances created. I don't use abstraction that much. Encapsulation and overloading are probably the 2 things I do the most, along with some inheritance. But let's start looking at encapsulation and what that really is. So encapsulation is the idea that I can encapsulate my data, and I can also have encapsulated methods. And really our constructor is also encapsulated in a sense. It's the idea that I have some private values in my class, but they can't be interfaced outside of the class, but there can be a public interface. And typically with data, we would create our fields or our variables as private, meaning we can only access those within the class, but we have a public accessor. And so I refer to these accessors as getters and setters. So I have this private int age. I cannot change age or retrieve the age directly from outside of this class, but I can use a setter to set the age or a getter to get the age. And the way we would do that, we have our private int age, that's called a backing field, and then I have a public interface to that, so a public int age that contains a get and a set, and a get simply returns the age value. Since I'm within my class, I can access age as the private variable, and I can set the private variable of age to whatever value is being passed. So when I'm passing a value, I can say my class instance.age equals 21, and when I'm getting it, maybe I'm putting into a variable called my age, I can use my class instance.age, and notice that these are capitalized. I can do this whole code of setting the private backing field and the public getter and setter directly on one line by using public int capitalizing age with a get and set. And that, in essence, creates this code for me with a lowercase age, or in some case, I might put an underscore in front of age. I can also have a default value. So if I don't specify a set value, and I'm just creating maybe a new instance. I'm not passing it an age. The default would be 21. Or I can also create a read-only attribute just using a getter. That might be something like maybe an ID that I'm creating internally, never passing it a new ID, but I want to be able to get that ID that's created. Same thing with methods. In our constructor, we can pass our arguments of string fn, string ln, and string a, but internally those are going into the first name, last name, and age properties. Now I could have used the private variables here since this is being done inside the class. I could have made age a lowercase a. And same thing if I had variables for first name and last name that were lowercase, that were private, I could refer to those here. Same thing with a method. I can call a method and pass it a parameter. In this case, I'm going to pass it a retirement age. And assuming we have an age specified for that individual, in this case JBD, we said his age was 25. If I call this method, I'm going to pass it 67, and the method is going to return the retirement age, 67, minus the age, 25, which is 42, and so XYZ would equal 42. How this is calculated, I really don't care from outside of the class. It's what we would call a black box. All I need to know is what do I need to pass to it and what is going to be returned. What's the format that's going to be returned? In this case, it's going to be an integer, so XYZ would be an integer. We see this with the show method of the message box. So in the show method, I can call that method and pass it some arguments of welcome to C#, which is my text string or my prompt string, and then the caption being C# at SMCC. I send that to this black box of the show method. I don't really know what that code is, how it calculates or builds that dialog box. All I know is it displays a dialog box with my title and my prompt, in this case the default OK button. Notice that there are 20 different overloads here, and we'll talk about overloading in a few minutes. The next pillar we want to look at is the inheritance pillar. So here we create a class which would be a superclass. So I create a class called building. It has some properties or attributes of width, length, and height, and it has a constructor where I'm going to pass it the width, length, and height, and it would create an instance of building. And maybe it has some methods like open the door. But I can have inherited subclasses that are built on this superclass. So I might have three types of buildings. I have an outhouse subclass, and it's going to have a height, width, and length as well, but it's also going to have its unique property or attribute just part of the outhouse, and that might be the latrine depth. And when I create the constructor for that, I'm going to pass it the width, length, and height, which are part of the superclass, but I'm also going to pass it D here, which is the latrine depth. Here's another subclass. This is house. In house, I might need a property for how many bedrooms are there in this house. And so when I call this constructor, again, I'm going to pass it the width, length, and height, but I'm going to also pass it the B, which is the number of bedrooms. Now, a subclass might have a unique method that is not part of the superclass. So in this case, the subclass has a public method called start fireplace. And I should have probably a void in there, public void start fireplace. But we're going to assume that only a house has a fireplace, an outhouse does not, and a church does not, which is my third type of subclass. It also is inheriting from building, so it's got the width, length, and height, but it has another property, which is the height of the steeple. And that steeple height is not going to be in an outhouse or in a house. It's unique to the church. And there's a unique method here to the church, which is going to be public void ring bell. The outhouse and the house are not going to have that method. So when we create a list of the different houses, I can create a list of type building, and because these inherit from that building, in my list I might contain an outhouse, I might contain a house, and I might contain a church. And each of those items in my list would have those unique properties and methods in addition to the attributes or properties and methods of the building. The third pillar is polymorphism, which includes overloading and overriding methods. This is tied to methods, often as part of inheritance, but it need not be. These could be part of just a base class where we have multiple constructors or multiple methods that take different signatures or different parameters being passed. So overloading a method inside a class, if I have just a base class, I can have overloaded constructors. And each constructor here of my class has a different signature or different list of parameters. So here I have a string, and an integer, which happens to be first name, last name, and the age that we're passing. And we create an instance for this person with their first name, last name, and the age that's specified. But I can also create an instance of my class, passing it just the first name and the last name, both of those being strings, and no age. In this case, I have a default age of 21. So if I know the person is 21, I don't need to pass that age. It will just set it by default. So in this case, SS equals my class Sam Smith. Sam Smith would be 21 years of age, whereas John Doe, passing it the 25 of age parameter, John Doe would be 25 years old. Same with the methods. I might have a method called years to retirement. In this case, one method takes a parameter of retirement age, which is an integer. And so if I pass 58 to my object of JD, John Doe, and his age is 25, it's going to return the retirement age minus the age, which is 58, minus his 25, and XYZ would equal 33. But for Sam Smith, if I call it years to retirement and I don't pass it a value, it's going to use this method. It's an overloaded method of years to retirement, but the signature is different. The parameters are different. There are no parameters. And so here it's going to calculate the number of years by 67, and that E should not have been there. Sorry, it should be 67 minus age. So 67 minus his 21 is going to return 46 years to retirement. So it uses whichever method can be applied based on the signature or the arguments being passed to it. So it's contextual. We see this with the message box, the show method. I can pass it two strings, one being the text or prompt and one being the caption, and it builds a message box with the caption and the prompt and the OK button as a default. Or I can also pass it the text, the caption, and a different request of message box buttons, and it will build that dialog box with those three different buttons that I've specified, along with the title and the prompt or text. Same thing, I can pass it 5 parameters, in this case the text or prompt, the caption, the buttons I want, an icon I want to have shown, and which button should be the default, and it will build that dialog box based on those arguments. So I have 3 different arguments here, and as we see here there's actually 20 different variations of this, but I can pass it different arguments and get a different result. That is overloading. Another type of polymorphism is contextual. So here I have my superclass, but then in each of the subclasses, outhouse, house, and church, I have a method that is the same, calc value. It returns an integer, but the value that's calculated on the square footage for an outhouse will be different than the value calculated for a house versus maybe the value calculated for a church. Which one of these it uses is going to be based on the type of object that instance was created from, whether it's an outhouse, a house, or a church. That's another method of polymorphism. I might create a method inside my building class that specifies how to calculate the value, and I can make that a virtual method and allow it to be overridden in one or more of the subclasses. Here the outhouse class overrides that calculation, whereas the church subclass overrides it, maybe with a different method to calculate the value. But the house doesn't have an overridden method. It would use the method that is part of the building superclass. And then finally we have the abstraction pillar. An abstraction is the idea that I'm going to create an abstract class, and I cannot create any instances of that abstract class, though I can create a constructor for it. It may contain attributes, and it may contain methods, and it may contain abstract methods. The abstract class requires me to create subclasses in order to create instances. And we call those subclasses oftentimes concrete classes. So we have the difference between an abstract class and a concrete class. So again, the abstract class is just a superclass that cannot create instances, and the concrete classes are child or subclasses that may create instances. Now, if I have an abstract method, it requires the concrete class to create an overriding method of that same name and same data type. If I do not create that method, I will get an error. So this is a way of specifying that the subclasses must have this method and implement it. Let's look at how to create the abstract class and a concrete class. So in code, we would create our class the same way as we normally do, but we put the abstract keyword in front of it. And I can have properties that are part of that abstract class. In this case, I have width, length, and height. And those are going to be part of every concrete class then. I can have a constructor in which I'm passing it the width, length, and height for those properties and populate those. But notice my comment here. I cannot create a direct instance of the building class. I have to go through a subclass or a concrete class to do that. I can have a method in that abstract class. In this case, I have square feet, which can return the width times the length. And I can also create an abstract method. Now this abstract method, notice it looks like a normal method definition, but there's no body to it. There's no brackets. Instead, I have a semicolon at the end and the keyword abstract. This requires then that every concrete or every subclass must implement the calc value method and return an integer. So over here then is my concrete class of house. It inherits from building. I added an additional property here of bedrooms, which I can get and set, so the number of bedrooms in the house. I have a constructor for public house, in which I'm passing it the width, length, and height, which go to the base property, but also B for the number of bedrooms, and I populate that property here. The house may access the square foot method, so I don't need to duplicate that here, but I do need to implement the calc value method that was required as an abstract method. And I do that by overriding that abstract method and having it return an integer. And what I'm going to have it return is the number of square feet, which is going to calculate from the abstract class times 120. So it's $120 per square foot for a house. This might be implemented a bit differently in the outhouse concrete class, where we're going to take the square feet maybe times 10. And then for a church, again, might be calculated differently. Maybe it's the square feet times 200. Each one of those concrete classes must implement that calc value abstract method. So that then are the 4 pillars of object-oriented programming, including overloading as part of the polymorphism pillar. Sometimes I think of it as a 5th pillar. But this is what you'll find in pretty much every textbook, every description of object-oriented programming. These are the 4 pillars: encapsulation, inheritance, polymorphism, and abstraction. And then that other keyword of instantiation, or making instances of the class. You will find these in every object-oriented programming language. The coding might be a little bit different than what I've shown here in C#.